All right, so some of you have been having some trouble with this exercise. So I'm going to go over two very quick examples to help you out. Now remember, we are graphing inequalities, linear inequalities, and for the most part you should treat them exactly like linear equations. So let's take a look at this first blue linear inequality. And if this were a linear equation, in order to graph it, we'd first want to know or find our y-intercept. So when x is 0, y is 4. So we're going to come down here and we're going to graph x is 0, y is 4. And then we're going to look at our slope, 6 over 5. Rise is 6, run is 5, and then we can go up 6. 1, 2, 3, 4, 5, 6, and then over 5. 1, 2, 3, 4, 5. And I want to be very, very cautious, very careful that I have the right points, because I suspect many of you know exactly how to do this, but you're just messing up on where exactly you put your points. So be very, very precise and careful where these points are plotted. So once you have the correct line, you should then decide two things. You should make two decisions. Where is the solution set? Is the solution set above or below the line? And we can look at that by looking at the sign of the inequality sign. Here, y, the value of y, is greater than the y values on the points on this line. So we want to shade above this line. Now notice y is going to be greater than, but it cannot be equal to any of the y coordinates on this line. So instead of graphing a solid line, we want to graph the line as being dashed to indicate that none of these points are a solution to this inequality. If this was y is greater than or equal to, then we'd want a solid line, but because it's just greater than, we want a dashed line. So that gets us our blue inequality. Now let's look at our green inequality. Y is less than negative 3x over 5 minus 5. So our y-intercept is negative 5. That's easy. And before I do anything, I'm going to notice that I have a negative slope here. So rather than seeing, or what I'd expect to see here is, instead of a line going upward from left to right, I want to see a line that goes down from left to right. So if we're going down from left to right, how am I going to accomplish that? Many of you make the following mistake. You apply the negative sign to both the numerator and the denominator. Now let's see what happens when we do that. Let's say we went down 3 and back 5. 1, 2, 3, and then back 5. 1, 2, 3, 4, 5. Now that seems right, but if you know anything about positive and negative slopes, you're going to know that this is wrong immediately, because notice the contour of the line. The line is sloping upwards, indicating a positive slope. But if the slope is negative and we have a line that's going up, we've made a mistake somewhere. So the right way to graph this is to apply the negative sign to either the numerator or the denominator, but not both. So we can either go down 3 and forward 5, or up 3 and back 5. So since I've already gone down 3, I'm going to choose to go forward 5 units. And here we go. Now I have a line that's going down from left to right, and so I know I have a negative slope. So assuming I've done everything else correctly, I've graphed my line correctly. So now I need to make those two decisions. Where should I shade? Should I shade above the line or below the line? Well, since y is less than negative 3x over 5 minus 5, then I'm going to shade below this line, not above it. If I were to shade above it, that would indicate that the y values of all the coordinates could be above this line, which is not correct. So we're going to shade below the line. And of course, since it can be less than but not equal to any of the points on this line, then the y-coordinate must be below and it cannot be equal to. So we're going to graph it as a dashed line, not a solid line. Now, we're almost done. In this exercise, it asks you to take this process a step further, and once you've graphed your system of inequalities, you want to see whether or not these points are a solution to this system. And remember what a system of anything is. It's finding where two functions intersect. In this case, these two inequalities, we're looking at the two solution sets. The solution set of the blue inequality is everything up here, and the solution set of the green inequality is everything below this line over here. And where do they intersect, or where do these solution sets overlap? Well, this is light blue, that's light green, and this looks like it's blue and green. This is the overlapping region. So any of these points are going to satisfy both of these inequalities. So let's see if if these 2 points are in the solution set in this shaded region. So 6, 9. 6, 9. That's clearly not going to be in the shaded region. But what about -4, 8? That's also not in the region. So neither of these points are in the shaded region. However, if one of the points was 9, -3, that would be one of the points, and you would just click it if that was 9, -3. But we're not going to do that since that's not one of the points. So far, if I've done everything correct, we should have the right answer. So let's see. And there we go. So in the last example, we were given two inequalities that were already in slope-intercept form. So they were very easy to graph. We could easily find 2 points by finding the y-intercept and then using the slope to find a second point. However, these two inequalities are not in slope-intercept form. So there are several ways we could go about graphing them, but the easiest way is to just solve them so that they are, or put them in slope-intercept form. And in order to do that, we're going to solve for y. So let's take the first inequality, the blue inequality, and I'm going to use a slightly different shade of blue so you can see it a little better. -2x minus 8y is greater than 32. I'm sorry, -32. So in order to convert this to slope-intercept form, all we have to do is solve for y. So we're going to add 2x to both sides, and that will give us -8y is greater than -32 plus 2x. Now, many of you mess up at this step because you are still thinking that you have to take this term and you have to move it to the other side. But remember, that's not what we're doing. Where you don't move anything to the other side. You cancel it out by applying the inverse operation. So if we have a -2x, we have to add 2x to both sides. Many of you, I find, will do something like this. Because you think, oh, we have to get rid of this, so we're going to subtract 2x. I hope by now you can understand why this is the wrong thing to do. What we are doing to both sides is we are adding 2x. So there we go. We're left with -8y is greater than -32 plus 2x. Now, in order to isolate y, to undo the multiplication by 8, we're going to divide by -8. And remember, if you divide this side by -8, then you must divide this entire side by -8. Now, immediately, as soon as you divide by a negative number, not a positive number, only a negative number, do you take this sign and flip it. And I'll illustrate this a slightly different way than I've illustrated it before. Let's leave this sign alone for a second. Let's just simplify everything else. So -8 over -8 is just +1, so that's going to leave us with y. -32 over -8 is a +4, and then 2 over -8 is going to be -2/8, which simplifies to 1 over 4, and then we just have our x. Now notice what happened here. Originally we had a negative coefficient in front of y, and now the coefficient of y is positive. It's a +1. And this was a -32, and it turned into a +4. And this was a +2x, and it turned into a -1/4 x. So all the signs in our expression, or inequality, switched. They flipped. So if all the other signs flip, then what do you think should happen to this greater than sign? It should flip and turn into a less than sign. And so we're left with y is less than 4 minus 1/4 x. And if you want to be a stickler about it, we can put it in slope-intercept form by taking this slope and x variable and putting it first. So we got negative 1/4 x plus 4. And so now we can easily see our y-intercept and our slope. Our y-intercept is 4, and our slope is negative 1/4. So let's graph that. Our y-intercept is 4, and our slope is negative 1/4. So we're going to go down 1 and forward 4. Now, we have to make two decisions. Do we shade above or below? Well, this is a less than sign, so we're going to shade below. And is this a less than or equal to, or just a less than? It's just a less than, so this line cannot be solid. It has to be dashed. Okay, and that gets us our first inequality. All right, let's move on to our green inequality. We've got 7x minus 4y is less than 16. So let's see how this shows up. 7x minus 4y is less than 16. All right, so we want to isolate y, so we're going to subtract 7x from both sides. Negative 4y is less than, and then 16 minus 7 x, and then we're going to divide both sides by negative 4. Divide both sides by negative 4. And the same thing happens here. Negative 4 over negative 4 is positive 1. We're turning the coefficient of y from a negative into a positive. Positive 16 over negative 4 is going to be negative 4. Because 16 divided by negative 4 is negative 4. And then negative 7 over negative 4 is going to be positive 7 over 4, since two negatives make a positive. So, and since all of our signs were flipped, negative to positive, positive to negative, negative to positive, then this less than should turn into a greater than sign. So now we have y is greater than negative 4 plus 7/4 x. So our y-intercept is negative 4, and our slope is 7/4. So let's graph that. Here's our green inequality. Our y-intercept is negative 4, and our slope is 7/4. So let's go up 7 and then over 4. And they meet right there. And now we have to make our decision. Where do we shade? Do we shade above or below? If y is greater than the line, then we shade above. And since it's just greater than and not greater than or equal to, then the line must be dashed. All right, so we've successfully graphed our two inequalities, and now we need to make our final decision. Is negative 5, 1 a solution to this system of inequalities? So let's take a look. We first have to identify our overlapping region. Here's our green region, here's our blue region, and here's our blue-green region, our overlapping or intersecting sets. So negative 5, 1. Let's go negative 5 and 1. That is inside the solution set. So that is a solution to both inequalities. And then finally 5, 0. 5, 0 is right there, and it is not inside the solution set. So let's check our answer, and we got it right.